shouldn't sing into this, should I? It's going to be recorded. See? Okie dokie. So the first one we're going to look at is this one here, okay? Actually, number 9. Oh, you can't see it because it's not up there yet. Sorry. We are on page 6 of 14, folks. Now, there's one little problem with this. It's the correlation of this, my ruler, which isn't obviously not really centimeters, right, to what yours is going to say, because yours is actual centimeters. You need your protractor. Yours broke. Who needs one? Let's see. Let me find the. I should have many more protractors than that. Anybody see the protractors around? No, that's all right. I should have a stack of them somewhere. There was literally a time when I had like 30 of them. Now, what was on your supply list, though? What was on it? You're supposed to have protractors. Here's a ruler. I should at least get one more. Darn it. Here, you guys could share this one. Ruler, anybody? All right, we should have enough around. I have ordered more, so I'm just waiting for them to come in. Well, you could just share yours with her. All right, so now, okay. No, I think we're good. I think we're ready. Okay, so we're going to start at A and go 10.5 miles west. But you're going to have to help me at first because remember, this my centimeters thing isn't actually centimeters, right? So notice your scale up here. Now a vector, what's a vector look like? You watched the video, right? With a line with an arrow, right? An arrow. And the length of the vector represents the magnitude, and the way it points is its direction. Okay? So we have two things up here that tell us one about direction, one about length and scale. So the first thing I have is 10.5 miles west. Okay? From starting at the point A. Well, west would be this way, because that's east. But I have to convert the 10.5 miles to my scale. So now we're not doing any trigonometry yet. We're only going to do graphical vectors. So we use scales, rulers and protractors for the graphical portion. So 10.5 miles is converting that over with, it's just like I do what we did with the conversions yesterday. But in this case, we have a fancy version of one. The version isn't like 100 centimeters is 1 meter. That's 1. This version of 1 is by our scale. 1.5 miles is 1 centimeter. So the miles will cancel, and we have 10.5 divided by 1.5, which gives us 7 centimeters. Now this is where you help me, because if you put yours on A, if I put mine on A, 7's at the middle of A, 7 centimeters is going to bring me to here. I know that's way too big, so where does yours bring you to when you do yours? I'm trying to get my ruler, the scale of my ruler correct. Where does it bring it on yours is what I'm asking. Is this supposed to go a little bit out this way or a little bit back? Right here? Farther? Good? Too far? How's that? That's pretty close, right? Okay, so see, so I went 7 centimeters. Now I'm going to draw that vector in on the map. I start at A, and I go the 7 centimeters over to the west. So that's 10.5 miles west. Bless you. Now, the next thing is 9 miles, 30 degrees east to north. So the first thing, I'm going to start at the head of this vector and go forth. Now, 9 miles, I have to convert that to centimeters. So 9 miles, 1.5 miles is 1 centimeter. That cancels my miles. 9 divided by 1.5 would be what? 6? Yeah. 6 centimeters. $30 west, no, 30 degrees what? What did it say? East of north, okay? So what that means is, if I put the cross right on the tip of the arrow. See how I'm doing that? Put the cross right on the tip of the arrow. And now I'll mark up the 30 degrees east to north. Now here's north, right? So east of north would be 10, 20, 30, right there. Okay? So now I got that marked. Now I have to take my protractor out of the way, turn and line up my ruler, meter stick, or whatever this thing is, centimeter ruler, and I'm going to go 6 centimeters in that direction. There we go, right? That's that's 30 degrees east to north, 6 centimeters representing 9 miles. Uh-oh. I thought I went over all these. How do I end up going north again? Oh well. We end up off the map. That's okay. It's not a big deal, but a little bit frustrating. Is yours in the same area? Well, because, yeah, it's fine. Doesn't matter. 4.5 miles And 1.5 miles is a centimeter, and 4.5 divided by 1.5 is 3 centimeters. So now we're going to go 3 centimeters north. I go right off the page. Great. At least you have a page to put yours on. Oh. So 3 centimeters north will take me to, from the arrow of that one, will take me up to there. Must have got moved or something. But anyways, so there's that. Now it says draw the resultant on the map. Okay? Well, the resultant, I can use my arrows up here. You have to use your ruler to use yours. The resultant starts where you start and ends where you end. So when we were adding these vectors up, the paths up, this vector went this way, this vector went this way, and this vector went that way, and we arranged them head of the vector to the tail of the next. Head of the vector to the tail of the next. And now we connect from the tail of the first vector to the head of the last vector. There's our result. Okay. Now you can see where colored pencils come in nicely, right? Yes. Oh, I just did 30 degrees east of north. 10, 20, 30. All right, so what? It starts where you start and ends where you end. The resultant in this case is called a displacement, and the displacement is your change in position from here to here. Okay? It's not really concerned with how you got there. Okay? It's just there. So, there's the resultant. We drew the resultant on the map. And then it gives you two things. One's delta S with an arrow. This is a little hard to read right here, but this is delta S with an arrow. Now, who remembers what that stuff is from the video? Okay. Jack? Okay. So what's the first one without the arrow? This is your what, Courtney? It's position, but the change in position is we call it the distance. The change in position with the arrow, okay? So the change where you're taking in taking in direction from where you started to where you finished. So not the distance you traveled, but from one to the other. That's considered the displacement. So the second thing here, this is displacement. Displacement is a vector, distance is a scalar. Scalars just have a magnitude to them. So what is the magnitude? How much is our distance that we traveled? You just add up the amounts. How much did we travel? Well, we traveled 10.5 miles. that's just 10.5 miles plus 9 miles plus 4.5 miles. That equals 24? 24 miles. The displacement has both a magnitude and a direction. The magnitude we're going to get by measuring the length of this purple arrow. This is the displacement. Purple is the displacement. We take our protractor, our ruler first. I put it on there. Now yours might be slightly different because mine comes out to about 9.2 centimeters, okay? So I have to change that. So, come on. What the heck? Oh, here it is. So 9.2 centimeters, but remember I need to convert that to miles first. What? 1 centimeter is 1.5 miles. So what's 9.2 times 1.5? 13.8 miles. That in itself is not only the displacement, that's only the magnitude of the displacement. Yours might be slightly different because you drew it, and plus I tried to get my ruler to match up. Okay? So what you should do is measure the length of it and convert it to miles. I just did it. But if yours is slightly different, do it differently. You know? Use a ruler. Here you go. Here's half of one. Well, 95% of one. Okay. See, so yours is slightly different. Did you guys get lower than I got? 6 centimeters? All right. Well, that's not much. All right. So now the other thing we're interested in is the direction of this displacement. Because it says the displacement, that means magnitude and direction. So I take the crosshairs, see the crosshairs of my compass, and I put them right there on the vector, and I read it off, and here's north, and now I have 10, 20, about 28 degrees west of north, isn't it? 28 degrees west of north. So this is my delta S with an arrow. Oh. You can obviously do it, but it's good to be able to do it when you're not looking at it. That's the key, right? Yeah. So that's what I went to smartboard class for them to teach me how to do stuff like that, and they didn't. It was just like pressing buttons and stuff. But I want to know, how do you juggle these things, right? Stuff like that. That's the important stuff. Okay. So we did that one. That's good. Now, let's see. On here I had 13.5 miles at 28 degrees on your key. And then the next ones we have to wait till tomorrow because you got to learn a little trig for those. But we got another one we can work on. Is project or page. Well, I have to look on this because it's different. So it should be like 13 in that range, or maybe 14. Oh, here it is. 12 of 14. Okay? So all right, so let's try this one. We have, starting at A, we go 10 miles east. Okay? East would be this way. And I just go 10 centimeters, right? Oh, no. No, you don't, right? We got to change this 10 miles to centimeters. Everybody with me? No? Oh, 5 centimeters. So we're going to go across, and I'm going to put my first vector on there. Starting at B, it says, uh-oh. Oh, that's all right. Yeah, what do you mean? It is at B. You going to take that? At least she's not from Syracuse, right? My friend's teaching in Syracuse. He just got a job there. Oh, it's elementary in the middle of the city. Yeah. He should be really good because he's like tall and like giant and scary. So he'll rough those kids into shape. But they'll probably, I would think they'll look to him as sort of a positive role model. He's a good guy, so. Huh? I don't know what the city is. I mean, what the school is. He's in the city of Syracuse. Yeah, in the city school. So, there's that. Now 6 miles at 45 degrees southeast. Well, we got to change that 6 miles. All right, I think I can see that it's going to be 3 centimeters, right? It's amazing, isn't it? I'm going to flip my protractor around. Now, I take the crosshairs. I keep saying this because people don't know how to use protractors. And I'm going to put the crosshairs on the tip of the arrow. Now, which way is southeast? Towards Alabama, right? So 45 is right here, so I have that marked. Now I can get throw this out of the way. And 6 miles is 3 centimeters, so I'm going to tilt it to match. See, I adjusted the scale, got it. Oh, come on. All right, so now 3 centimeters for me is going to take me to about there. Now yours might be slightly different, right? But that's my 3 centimeters southeast, and I've put the vectors arranged head to tail. And now it says 8 miles south, so that's going to be 8 miles equals 4 centimeters. and directly south, straight down. Did you guys end up somewhere over by that little lake there, right here? Okay. So now it's, all right, should I let you get caught up, or? All right, so now how would I draw in this resultant? Will? All right, so I would start where? Start at B and go till tip of the red. Okay, good. All right, good. See that? The resultant is the displacement. The sum of green plus blue plus red on mine is the distance. Whoops. Don't do that. So it says to, what is delta S? Well, delta S would be 10 miles, 6 miles, plus 8 miles equals 1624 miles. Now we go to purple. Now we're going to measure the length of purple. And what I'm coming up with is about 9.5 centimeters. But yours might be a little bit different. What did you get for yours? About 9.5? Okay, good. So 9.5 centimeters, that's going to be centimeters to miles, and 1 centimeters is 2 miles, so that's 19 miles. I want to point out to you the difference in the scales. This doesn't have a, east doesn't have a 0 degrees. When you have the 0 degrees, the positive x-axis is 0. Then this is 0 degrees right here. This is 90 degrees. This is 180. That's 270. Okay? So north ends up being 90. West is 180. And south is 270. So we're going to be around 300 or something, aren't we? Right? See that? So you have to interpret that off of here. So I can see that it's 40 degrees down, 10, 20, 30, 40. Well, 360 minus 40 is what? 320. So this is 19 miles at 320 degrees. That is the delta S. That's the displacement. Did you do? Yes. Yes. That's right. The next part says to find the x and y components. But did I talk about x and y components in the first video? I will in the second one, but I can just tell you now too, because it's not that hard. The x component is the part of it that runs along the x-axis, okay? So I'm going to draw that in now. Um, well, let's see. I'll use like this bright green one. So this is my x-axis part, and it goes out to the point of where, as far as it goes in the x direction, see? And now I'll do, oops, the y one, and that's the y component. So I have an x component that goes in the x direction of this big purple vector. Oops. Oh, there we go. All right. So the x component and the y component, right? To find those values, how am I going to get the values of these in miles? I could measure it, right? And when I measure it, I get 7.1 centimeters, which will be, since 1 centimeter is 2 miles, that's for the x, I get 14.2 miles. And then for the y component, that's all right, Vera. You're a little early. Next class. You can just hang out for a minute. So the y component, just real quick, is 6 centimeters, which would be how many miles? 12 miles. Have a nice day.